All right, in this video, we're going to talk about how to convert back and forth between degrees and radians. So the examples that we want to work are right here. So first off, we want to convert 30 degrees to radians. All right, and so 30 degrees, oops, let me make that a little larger. All right, and to do that, what we want to do is to use this conversion factor. We want to use the fact that 180 degrees equals pi radians, all right? And so you either have to multiply by pi over 180 or 180 over pi, right, to convert this, all right? If you have any trouble remembering which way that goes, right, is the trick is to, or one trick is to use fractions, right? And so what you want to do is you can always write the value that you are converting as a fraction itself, right? 30 degrees, right? You can, however many degrees it is, just put it over 1, right? And then to figure out whether it's pi over 180 or 180 over pi, right? The easy way to remember is that the denominator needs to match the same units as the units up here. So up here, the 30, the numerator here, the number you're trying to convert, is in degrees, right? So that means that you want degrees in the bottom of the conversion factor over here. So it's going to be pi over 180, all right? All right, and then you just multiply it like a fraction and reduce, okay? I'm going to go ahead and reduce it right off the bat because that's the better way to do it, right? You could go ahead and multiply, you'd get 30 pi over 180, and then reduce it that way if you want to, right? That's perfectly fine to do it that way, but then you'll have to deal with larger numbers. So I'm going to go ahead and reduce it. I know that 30, right, goes into 186 times, right? So 30 goes into itself once, and 30 goes into 180 6 times, okay? So I'm going to go ahead and reduce before I multiply. Usually a little easier to do it that way, although here it probably doesn't matter too much. All right, then I would multiply 1 times pi is pi. On the bottom, 1 times 6 is 6. All right, so 30 degrees is pi over 6 radians. All right, next up was 45 degrees. We want to convert that. So 45 degrees, right? Again, we're going to multiply by the conversion factor, either, which is 180 degrees equals pi radians. So we're either going to multiply by pi over 180 or 180 over pi. To remember which one it is, right? Remember that the numerator here, the units of the numerator need to match the units of the denominator down here. So this is degrees, so that means degrees is going to be down here, are going to be down here. So that's 180 degrees on the bottom and pi on the top. Okay. All right, and so then again, I am going to go ahead and reduce. You can multiply and then reduce if you like. But here, right, 45 does go into 180 evenly, right? So because two 45s will give you a 90, right? And 90 goes into here 2 times. So that means 45 will go into 180 4 times. So 45 goes into itself 1 time. 45 goes into 180 4 times. So this is going to be pi over 4 radians. All right, 60 degrees was the next one. All right, so again, 60 degrees, I want to convert that to radians. So I know that degrees need to be in the bottom of the conversion factor, right? So 180 degrees goes down here. That means pi goes on top. And then go ahead and multiply that as a fraction. And here, this reduces again. 60 goes into itself once, and it goes into 180 3 times, right? So you get pi over 3, multiplying across. 1 times pi is pi, 1 times 3 is 3. Okay. All right, and so 60 degrees is pi over 3 radians. Now, you might ask, well, what if it doesn't? All those were nice and they canceled out nice and evenly. What about 11 degrees, right? If I want to convert that. You do it exactly the same way, right? Write this as a fraction and then put 180 degrees on the bottom because this is in degrees and pi on top. And then here nothing reduces, right? 11 doesn't go into 180 evenly, so you're better off just writing it as when you multiply across the top, you get 11 pi. Across the top, you get 180. So 11 degrees is 11 pi over 180 radians. All right, let's take a look at the other direction. In this direction, we're going to be converting some radian measure, and we can tell, right, that these are radian measures because there's no degrees here, right? It doesn't say 2 pi over 3 degrees, right? You can see there's no degree symbol, so we assume, right, that those are in radians. All right, so 2 pi over 3. I want to convert that into degrees. So this one is already a fraction, so there's no need to make it a fraction like we did up here. 30 wasn't, it's a whole number, or integer, so we can express it as 30 over 1, and that helps us think about how to make this calculation. 2 pi over 3 is already a fraction, so there's no need to do that. And so we know that we need to multiply by the conversion factor, and the conversion factor is going to either be pi over 180 or 180 over pi, right? And so again, the units need to match up. The units up here with this one need to match with the units in the denominator here. This is measured in radians, right? And so we'll put pi radians on the bottom this time, and then 180 degrees on the top. All right. Okay, and so now what we can do is, again, you can multiply these across the tops and across the bottom, just like you multiply any two fractions, and then reduce. However, I'm going to reduce first because, again, it makes it easier. You're dealing with smaller numbers, in my opinion. So the first thing to notice is that I have a pi here and a pi here, so that is a common factor between the numerator and denominator. So the pi's cancel each other out. Okay, and then 3, right, will go into 180 evenly, so I can reduce that a little bit, right? 3 goes into itself 1 time, and 3 goes into 180 60 times. Okay. And so now I've reduced everything. Now I'm going to multiply. 2 times 60 is 120. 1 times, I guess I should have put a 1 here. And here probably, if you're wondering about that. Pi goes into itself 1 time, pi goes into itself 1 time. So on the bottom I have 1 times 1, right, which is 1. And 120 divided by 1 is 120. Don't forget the degree symbol right here. This is in degrees, right? So make sure you put that. All right, so 2 pi over 3 radians is 120 degrees. All right, next up is 3 pi over 4. All right, so this is in radians, and we want to convert it to degrees. We know that we need to multiply by the conversion factor, either pi over 180 or 180 over pi. And so the key to remembering what goes where is what's called dimensional analysis. I haven't been calling that, but that's the technique, right? And so this is in radians, so we want to put radians in the conversion factor down here. And that means degrees. The other part will go up on top, right? And then, again, multiply these out and cancel, or go ahead and cancel and then multiply, which is what I'm going to do. Pi goes into itself once. It goes into itself once up here. Looking for common factors between the top and the bottom, I can see 4 goes into 180, right? 4 goes into itself 1 time. It goes into 180 45 times. Okay. And now that I've reduced everything, I just multiply across the top. So I have 3 times 1 times 45. 3 times 45 is 135. 90 plus 45. Multiplying across the bottom, 1 times 1 is 1. Right, and so I get 135 degrees. Don't forget, right, to put the degree sign on that. So anybody coming later will know, okay, that's in degrees, 100%, not radians. All right, last one is 5 pi over 6. And just like the other ones, this one's in radians, right? There's no degree sign here, so this is angles measure is radians. And so radians will be on the bottom of the conversion factor. So that's the pi, and the degrees will go on the other side on the top. Okay, and so again, I am going to cancel and then multiply. You can do it the other way, it's fine. It's just probably a little less efficient, a little more difficult to do it that way. And then 6 goes into itself once. It goes into 180 30 times, right? So, and then multiplying across the tops. 5 times 30 is 150. And then 1, right, is essentially all I have on the bottom. So, and that would be 150 degrees. Make sure, again, you put that in the little degree symbol for that one. All right, I believe that is it on this one. Yeah.